So this is our second to last lesson of the unit. It is our day 2 of the elimination lesson. Yesterday was day 1 of that method. And yesterday's problems all were able to solve right away. So it was set up in a way that made it easy to eliminate. Today they're not necessarily already going to be set up that way, so you need to find out how multiplying equations by a factor can help us solve the system. So every method that I've taught you, you'll find has pros and cons. So for example, if the equations are given to you in slope intercept form already, then maybe you want to solve by graph. If they're really short equations, then maybe by substitution. I think in all other situations, I think elimination is best. So you'll see that by multiplying each side of one or both of the equations, that it's easier to solve it. And understand that multiplying each side of an equation by a factor makes an equivalent equation. We actually saw that early on in the unit, so reinforcing it. I record every day, so there's never an excuse for you not taking notes for one, because you always go back onto the lesson. But it's really hard to catch you up, for example, with miss multiple lessons, 45-minute tutoring is never gonna catch you up on hours of lessons. So they really are all there, everything you will need to know. Not to have to watch every single moment of it, but enough to get the idea. You do have a practice for lesson 16, which is what you're doing today, and you should have a decent amount of time to work on it. So, and I know yesterday you didn't have any time to do your lesson 15 practices. There's actually 2, both pretty short, but work hard today in the lesson, try to understand. Keep in mind, these are the next really important deadlines and assessments. So no more quizzes for quizzes are your checkpoints. You should always see how you did the day after they're usually. So do corrections if you want to let know that the assessments, the unit assessments are always for. So binary check is also worth a lot of points. If you were one of the people that didn't get full points on your minor check last time, then you saw a big impact on the grade. These are supposed to be good grades because I'm giving you points for things that you're supposed to do as a student. So it goes in what category your minor check? Which is how much of your grade? 20%. So 20% of your grade is just you taking notes. Involves no you solving things for accuracy. Just take your notes, do your job as a student. I think it's really hard to learn math if you're not writing down. Then you have your unit tests, which are closely aligned to the study guides, all of which are available at the top of Schoology. Falling quite behind, focus on those study guides first, so that at least you're getting great on those that are 60%. Okay. And I did send a message through Parent Square, Student Square, about all the study guides, all the extra credit opportunities, most classes, it's just pay attention in class and do well on the test. There's not all these supplemental things. There's so much out there, and now your parents know about it. So do it. All right, we're gonna go ahead and get started. So look at this system of linear equations. Table 9. Are there any common coefficients? No. Okay, so common coefficients are what we need in order to solve by elimination. We still can, but we just have to add an extra step, and that's what we're going to learn today. But first, you're going to see why this extra step that we will add isn't changing anything other than making it easier to solve. All right. I'm sure if you've been paying attention, you know by now that if it's just asking you for the solution, what is probably the easiest thing to do on your test if it just wants the solution? Use Desmos. Desmos and other graphing calculators too are typically very user-friendly. For Desmos, you don't even have to put it in slope-intercept form. You can just type equations in different cells, and it will graph it for you. So if it is just asking you for the solution, which is the coordinate where they intersect, then yeah, type it in Desmos. I won't know what that is. But if it's a constructed response that is making you show work, or there are questions on your test that require you to know the steps of all the methods to see where the error was made and all that, then that is why we're teaching them. Okay, but we're telling you right off the bat, if I graph this system, my solution is 1, 1. Right, where they intersect is my solution. Good on that so far? Now, when both sides of an equation are multiplied by the same value, it's the same sign. If I were to multiply both sides of an equation by the same value, is it still true? Yes. And that is what we will be doing to create a common coefficient. But before we do that part of it, just kind of think about it now. I think it's easier for you to understand that it is still true when there's numbers. So let me take just one of the equations from our system. We know that the solution was 1, 1, so let me put that in. 1 for the x and 1 for the y. Class, what's 2 times 1? And what's 2 minus 1? So we have an equation that is true. Let's now multiply this top equation by a factor. Table 2, pick a random number between 1. So if I were to multiply this whole equation by 8, so that means I'm multiplying every single term, including on the other side of the equal sign. We're going to see if it's still true. So class, with 8 times 2x? What is 8 times negative y? Negative 8y, good, because what's in front of the y if it's not written? A 1 is negative 1, so negative 8. And then 8 times 1 is, so I multiply this entire equation by a random factor. Normally you don't pick a random factor, normally, but right now we're just proving, does it still make it true? So if I were to plug in this solution into this equation, it would be 16 times 1 minus 8 times 1 equals 8. Class, with 16 times 1. What's 8 times 1? Is 16 minus 8, 8. So still true, even though I multiplied it by a random factor. As long as you do it to both sides, then it is still true. Questions on that? Okay. Now, normally you don't pick random factors. Normally you pick a factor that will create a common coefficient. So I'm gonna scroll up. Sorry if you're a slow note taker. We'll come back to that, don't worry. But looking at our system, you have to think what would probably be easiest to do to create a common coefficient. If I want a common coefficient on the x, then I'd probably multiply the top equation by 2, because that's how I can go from 2 to 4 by multiplying. If I want a common coefficient on the y, then maybe I'll multiply the top equation by 4. All right, it's up to you. For this one, we are going to multiply the first equation by 2. So kind of similar to what we just did, except multiplying by 2 will create a common coefficient, whereas 8 would not. Table 3, can you tell me what I get from multiplying this equation by 2? So multiply each term by the factor that you said would create a common coefficient. Okay. So I'm going to pair it with the other equation that I did not do anything to create a new system. So let me see, I think I have more room here. So here's my equation that I just created. I'm going to pair it with the other equation that I did not manipulate at all. So the 4x plus 4y equals 8. Now it is something that I can solve with elimination. Yes? It doesn't have to be. You could, like, if you wanted to multiply the top one by a -2 to have that go on, you can. It's just whatever you think is easier. Okay, but you have to pick a way. So I want a common coefficient on the x, so I multiply the top one by 2. And now we can proceed with what we learned yesterday. So table 4, we made a common coefficient on the x. Do I have to add or subtract to cancel it out? In this one, you have to subtract. So when it's the same sign, you subtract. So even if those were both -4s, I would still subtract them to eliminate. 4x minus 4x is what? And that's why we did it. That's why we did it, in order to eliminate one of them. Because you had to do it there, you have to now do it to the rest. So now I have -2y minus 4y. What's that going to be? So you can use your calculator for the numbers. It probably won't figure out the variable for you, but you can do -2 minus 4 in your calculator. Because you have to subtract in this one to eliminate the variables. You have to subtract these now too. That makes sense? I don't think I've heard the right answer yet. Okay, -6y is what we get. And then 2 minus 8 is -6. Any confusion? So I have to subtract these now because I have to subtract the x's to eliminate. Table 5, what do I need to do to isolate the y completely? Divide each side by -6 so that I can get the y alone. And I get that my y value is 1. How do I get my x value? Plug in the y into one of the original equations. And I would do one of the very original equations, like the ones that they print on your paper. Okay, because you could, I don't know, multiply something wrong. But just plug into one of them. Which one do you think would be easier to plug into?
Table 6, can you pick? Which one do you think it would be easier to plug in the y? All right. And that is your guys' choice, up to you. So long as you do the math right, it shouldn't matter which one you plug into, as long as it's one of your originals. So we're saying the y is 1. So make sure you plug in the right spot. Class, what is 4 times 1? Sorry, I'm running out of room. But yes, it is 4. What do I need to do now to start isolating the x? And do that on both sides. I get 4x equals 4. What's opposite of multiplying 4? And we get that x equals 1. So do we get the same solution that we got from graphing? Yes, we do. So you can fill in this little blank. Yes, we got the same solution, even though we multiplied one of the equations by a factor. All right, now notice this graph that is on your paper. It is the new system that we created. The 4x plus 4y equals 8 and the 4x minus 2y equals 2. That's after we multiplied it. The graph looks exactly the same, aside from the new equation. So doing that makes an equivalent equation. It just makes it a little easier to solve with elimination. Questions on that? So now we're going to practice it, because like I said, although you could use graphing to just find your final answer, the test questions aren't necessarily going to always ask you for your final answers, as you might have seen from the practice. All right, so here's the steps typed out for you. The only thing I would add is that you need to check for a common coefficient. All right, you need to check for common coefficients. If there's not one, then that's where the multiplying comes in. If there is one, then you can already move on to what we learned yesterday. But there are multiple ways to do the same problem. It depends on what variable you choose to eliminate, or you choose to multiply it by a positive or negative. So you just have to apply the correct math to it. Right? Let's look at A. Table 7. Is there a common coefficient in example A? There is not. So that means we have to multiply one or both of the equations by a factor. So you have to be strategic in it. Is it easy to go from 2 to 3? Fine. Right? No. Is it easy to go from 2 to 8 by multiplying? So then that's probably the one I'm going to want to change. What should I multiply the bottom equation by? 4. 4 or negative 4 up to 2. Depends if you want to end up adding or subtracting. So I'm going to copy over the first equation that I'm not doing anything. And we are going to multiply the bottom equation entirely by 4. So table 8, can you tell me what we get from multiplying? Okay, great. Any questions on that? All right, it creates our new system of equations. You'll see sometimes it's difficult to show like that's a system. But yeah. This now has a common coefficient. Now I can move on with the rest of the steps. So table 9, do I need to add or subtract these? Okay, 8 minus -8, what's that? No, 16. 8 minus -8. So then we should instead do what? We should add 2 to cancel out your y's. 8y plus -8y is 0. You now have to do to the rest. You now have to add these other. Table 1, what's 3x plus 8x? Good. Table 2, what is 7 plus -3? Good. Class, what does x end up being? -3. So when we divide each side by 11, that's why we like elimination. It makes it easy to solve for the first variable. It's still pretty easy to solve for the second one though. How do I solve for the y now? Plug it back into one of your original equations. So we have the x. I mentioned yesterday, usually once I have one of the parts of the coordinate, I'll write them. I'll start writing it. Helps me remember that there's another part to solve for. Since this is x, would it go first or second? Now we're going to plug into one of the equations and solve for y. So it's equal 3, which means we plug in and solve for y. Okay. So if I'm plugging into the top equation, then it will look something like this before I start simplifying. So notice I replace the x with equals -3. Anytime you plug in, use parentheses so that way you remember that you're multiplying, not doing -3. Class, what's 3 times -3? -9. And now it's a 2-step equation, what we started our unit with. So what do I need to do first to isolate the y? Add both sides. 8y equals what's 7 plus 9? Opposite of multiplying by 8 is, and y ends up equaling. So if I were checking my answer by graphing, which I always should, that's starting place all the methods. But I would look for it intersecting at that. I'm gonna have you guys try the one that's underneath this one. C, not B, because I mean you might not want to solve B, but B will be harder. Try C for right now, and we'll check it. So just because someone did it a different way doesn't mean you're necessarily wrong. Just, I don't know, don't erase it completely yet. There's things you can do that are wrong, but there's multiple ways you can get the right answer. So in C, do we have a common coefficient already? No, so that means if I want to solve by elimination, which is what we're practicing, I need to multiply one or both of the equations by a factor. So see what your options are. Would it be easy to go from 2 to 3 by multiplying? All right, what about from 1 to 4? What could I multiply by? So if I choose to multiply the bottom equation by 4, that might be like the least labor intensive. Multiply by 4, multiply by -4. If you want to add the equations, up to you. If you want, well, maybe I'll wait for a second. There is another way you could try to get the x to eliminate, but that would involve you multiplying both equations, which works smarter, not harder. I'm not saying that won't still get the right answer if you do that. Just this seems to be easier. So let's do that. The top equation, I'm going to leave as is. I do not need to manipulate that one at all. The bottom equation, I'm going to multiply entirely by 4. So table 9, can you tell me what this equation will be after multiplying it by
4x, 4y, 108x.
Okay, great. So it's really important you multiply the entire equation, including the other side, the -8 by it too. Because whatever you do to one side of the equal sign, the other side. So great. We are now going to look at these equations that we made. They should have a common coefficient now. On the y's. Table 1, and you guys could have done it differently on your paper, but the way that it is on my screen, what I need to add or subtract these to 8y, or sorry, 4y plus 4y is, so that wouldn't eliminate them. So instead of adding them, I should subtract. The same sign subtract. If they were both negative 4y, I would still have to subtract them. Same sign, you subtract them. So 4y minus 4y is 0. That's what you want, is to eliminate one of them. And whatever you have to do to eliminate it, you now have to do to the rest. So table 2, not weighted this time. Negative 3x minus 8x. What is that? Okay, great. So your calculator can do the numbers. You can do negative times 8, but then you have to remember to put the answer. All right, so negative 11x equals table 3. What's 12 minus a negative? Good. Don't believe me, put in your calculator. Don't be shy, please calculate. Let me see. So we have to subtract here. We have to subtract. Well, table 4, what does x end up being? -4, but so x equals -4. Part of my answer has so I have this part of my final answer. Part of it. What's missing? So how do I get the y? Get the y. So that's to this stage. We know what x is. In order to find y, if I know what x is, I'm just going to plug it back into what is my original is. So table 5, which one do you think would be easier to plug the x? Okay. And it's up to you. I do think the bottom one would be a little easier, but it doesn't matter. So as long as you plug it into the right location, this is an x.
Positive 12. Isolate the y. What's harder? How do I cancel it? Subtracting 12. Class was 12 minus 12. And opposite of multiplying by 4. And what is 0 divided by 4? 0. So that is 0. Questions? Okay. So we're going to add one more situation you might see, and then you'll try that situation. So scrolling back up. In example B, is there a common coefficient? Is it easy to create one? So I can't easily go from 3 to 4 by multiplying, right? And same with 2 to 13. I probably wouldn't want to multiply by decimal. So not quite as easy as the ones we've seen already. You can still do elimination, but you'll now have to multiply both equations by something. And that something, it just depends on which one you want to make. So you don't have to write this down yet, but if I want to cancel out the x's, then I kind of just multiply by the opposite. Because if I do 4 times 3 and 3 times 4, then I'll get a constant. Or if I want to or if I want to eliminate the y's, then I would do those opposites. 13 times 2 is 26, and 13 is 26. So now we'll multiply both equations. Which one do you guys think would be easier to eliminate? Yes, y. Raise your hand if you want to eliminate yes. Raise your hand if you want to eliminate y. I don't know, it's pretty even. Up to you. I think the x will be easier, so I think I have that in my notes from last year. So I'll do the y so I can show you both. That you get the same answer no matter what way. If I want to eliminate the y, what would I have to multiply the top equation by? 13, good, I said it just a minute ago. And then that means the bottom one would have to be multiplied by. And now do that. So the top one, when I multiply by 13, I have my times table, so I get negative 39x plus 26y equal to 52 less. And that's me multiplying the top equation by 2. Now multiply your bottom equation by 2. So 2 times 4x6. 2 times negative 13y. Y. And 2 times 5 is variables in this process. All right, so now I have the common coefficient on the y. Table 4, do I need to add or subtract these two? Do they have the same sign? So since it's the same sign subtract, don't have the same sign. Okay, I don't have a key one for half. Right? The same sign subtract, don't have the same sign.
cancel out. And because you had to add to make it cancel, you now have to do the table 5 negative 39. And table 6 was 10. And table 7 was opposite of multiplying one. Whatever you do on one side. And class X ends up equaling negative. We still need to find the y. Any questions on that first question? How do I find the y? We're plugging x back into one of the originals. Table 8 with original is plug into. Class negative 3 times negative 2. And now it's a two-step equation. Start with what's farther from the y. Table 9, how do I eliminate the 6? I get 2y equals class 4 minus 6. And table 1, what would I do to cancel out the 2? Divide by it. And then y ends up equaling negative 1. Pair them together to be written as pair. My final answer ends up being negative. Good. Okay. You have one more to try. We'll go over, or at least I'll project it in about 5 minutes, the example. And then after that, you are just working on your practice. So I promise to show you what that one looked like if you wanted to eliminate the x first. So let me do that real quick. Okay, so, oh wait, no, I'm looking at the wrong one. This one. If you wanted to eliminate the x term, then you could have multiplied the top one by 4, the bottom by 3, and we still get the same answer. Negative 2, negative 1 was our answer for B. Okay, our equations end up looking a bit different, but they're still equivalent to our original system. Any questions on that? Okay, I'm gonna leave this up as an example. You're working on part D as you try. So there are multiple ways you could have gone about it and still be correct, but in part D, it's probably easiest. Well, I guess it's not. They're equally as hard, I guess. On mine, I decided I wanted the y coefficients to match. So I multiplied the top one by 2 and the bottom one by 3. If you wanted the x coefficients to match, then you would multiply the top one by what? 5. And the bottom one by, this depends on your preference. So I wanted the y's to cancel. Here's what they look like after I multiply them. Common coefficients on the y, they have opposite signs. So I add them to eliminate. You could like play around with these being positive or negative if you want to do this step a certain way, but I don't mess around with that. I just do it as is.
When I combine my equations, I get that x is -2. I plug -2 back into the original and solve for y. So regardless of how you did it, if you got -2, 1 as your final answer, then you are correct. Question. Monday, we are just doing, I wouldn't pack up yet. Please don't pack up. Two more problems. Monday, we're just doing a short lesson on word problems. We've kind of been doing word problems all throughout. So kind of a bit of review. Tuesday is that binder check and study guide work time for you to ask questions in class. Wednesday is your first attempt at the test. Just because we do planned retakes in class doesn't mean you should just not be prepared by Wednesday. Okay, you need to be ready, and if it's the first time, then you get a 3-day. Think of it that way. If I fail it, then I have another chance Friday. Like, you want both to be good. Any questions? I usually assign intentions for throwing things. I don't deal with childish baby behavior.